All right, so this problem reads that Miguel is in a lighthouse on a cliff. He sees two sailboats due east of the lighthouse. The angles of depression are 33 degrees and 57 degrees. And we have to find the distance between the two sailboats. So essentially what we're doing in this problem is trying to figure out the distance between point D and point A, or the distance of this line segment right here. So what we're going to do basically is first find the distance from this point all the way to this point. And then we're going to find the distance from this point to this point and then subtract those two values. Now, the reason for this is pretty simple. Let's think about it for a minute using some hypothetical numbers. Let's say from here to here, you had a distance of, say, 8. Now, this is not true. I'm just showing this as an example. And let's say from D to A, it was 12. Now, if we add those two distances together, that would give us a total of 20. So we're pretending from here to here is 20. And then if we took 20 and we subtracted this distance of 8, what we would have left over is 12, or the distance from D to A. All right, let's start by figuring out what the distance is from this point all the way to this point. Now notice that basically this distance is the base of this right triangle right here. So let's go ahead and just sketch an approximation of that right triangle. And they give us the height of this right triangle, which is 195 feet. Notice I had to add the height of the cliff to the height of the lighthouse. So this height is 195 feet. Now we're trying to find the base of this right triangle. We're just going to label that X for right now. And they actually give us this angle right here, which is 33 degrees. Now the reason I know that this angle is 33 degrees is because this angle and this angle right here are alternate interior angles. Notice we have a pair of parallel lines. We have line E and line B, which are parallel to each other. And then we have this transversal right here. And angles that are on alternate sides of our transversal are considered alternate interior angles. So what I'm going to do now is figure out which trig ratio we should use to come up with the value of X. Now we know the longest side of a right triangle is the hypotenuse. All right. And in this particular problem, the hypotenuse is not involved because the hypotenuse is not this 195 or this X. Now, the side that is not part of your angle, meaning that this line segment does not form this 33-degree angle, is always going to be considered your opposite side relative to the angle in question. And this side right here is going to be our adjacent line relative to this angle. So what trig function is formed by the opposite side and the adjacent side? Well, that would be a tangent function. So what we're going to do is we're going to set up an equation that the tangent of 33 degrees is equal to the ratio of the opposite over the adjacent. And we know what the opposite is. We know it is 195. We're trying to find the length of the adjacent side, which we have labeled X. Now, a shortcut you can use for whenever the numerator is given and you're trying to find the denominator and they give you the angle on the other side is you just take that numerator and divide it by whatever you have on the other side. In this case, the tangent of 33. But why is that? Well, let's think about it. We are dividing by X. So the opposite would be to multiply by X. And that would cancel out sending X to the other side. And that would leave us with X multiplied by the tangent of 33 degrees is equal to 195. And then to isolate X further, we would have to divide this side by the tangent of 33 degrees. And we have to do the same thing on the other side. So we have to divide 195 by the tangent of 33 degrees, leaving us with just X on this side. So we know that X is going to be equal to 195 divided by the tangent of 33 degrees. All right, so let's go ahead and input 195 divided by the tangent of 33 into our calculator. And that gives us a value of about 300. So we would say that the value of X is approximately equal to 300 feet. So let's go ahead and label the distance from here all the way to here 300. All right, now that we know the distance of this line segment right here, we have to find the distance of this line segment right here from this point to point D. And we can see that this distance right here is the base of this right triangle right here. So let us go ahead and do a quick sketch of that right triangle. And it has the same height of the other right triangle, which is 195 feet. And we're going to label this X once again. And the angle that is kind of given is this angle right here. And this angle is equal to 57 degrees. And that is because this right here is the transversal, in this case, of these two parallel lines. So we would say that this angle right here, which is 57 degrees, is equal to this one right here because they are alternate interior angles. So this angle is 57 degrees. So we have the same two side lengths that we did from the last example. We have the line that is opposite of our 57-degree angle and a line that is adjacent. So what we're going to do is we're going to write the tangent of 57 degrees is equal to the ratio of our opposite side length, which is 195, over the side we're looking for, which is the base of this right triangle. All right, now last time I showed multiple steps so you can isolate the x, but remember when x is your denominator and you are given a value for the numerator, the shortcut is you just take that numerator, which in this case is 195, and just divide it by whatever is on the other side of your equal sign, which in this case is the tangent of 57 degrees. So let us go ahead and put this into our calculator. So we have 195 divided by the tangent of 57 degrees, which is approximately equal to 127 feet if we round it. Because it says 0.6, we have to round this as a whole number to 127. So we're going to say that this length right here is about 127 feet. So if we took this total distance of 300 and we subtracted 127 of it, what we would have remaining is the distance from D to A. So we're going to take 300, and we're going to subtract 127, which is going to leave us with 173 feet. Now notice in this problem, they did not ask us to round to the nearest hundredth or the nearest tenth. So as I went along, I just made a decision to round everything to the nearest whole foot. But if a problem were to ask you to round to the nearest tenth or hundred or something like that, this answer could be slightly different. It could be like 172 or maybe 174. But I'm comfortable with just saying that the distance between these two sailboats is approximately 173 feet.